So on this final lecture of our course, I'm going to talk about what kind of exam answers I'm going to expect. And so this can be broken down to 4 steps. First one is we're going to have on the course exam or on the finals, we're going to have only applied problems. So write down the problem in which way you have understood it. Step 2 is consider what methods you could use to solve the problem. And preferably if you list several, then pick which ones are you actually going to need. Then the step 3 is the traditional mathematics problem that you might have earlier done in school. So apply one of the methods. And then step 4 is the most important one. So interpret your answer in so-called normal language. And so if you have looked at actual scientific articles, this is really similar structure. So while other formats exist, the typical scientific texts of today is structured something like this. That there's first an introduction, what the background is, well, in a study, there would be what the authors have done on the same field and a bit of literature study, and why there is still some missing piece which you're going to solve in your brilliant research. Then the methods that you're going to use in your research. And for example, if you are a roboticist, this methods part is not I'm going to use a robot, but instead it's going to tell you what kind of a problem solving methods you're going to use and apply to that robot. So that's research methods, not what are you doing. Then results would tell, okay, you applied those methods, what are your results? And in some kind of a longer research, then this would be telling that what happened during the research project. If there's a lot of results, then it might be necessary to have the separate analysis step, not necessary in our exam. So this is then looking at the results. If you have a ton of numbers, and what the further processing of the results, and then discussion. So discussion is then practicality and okay, other people were working on the same field and what results they got. So in our introduction, we're going to rephrase the problem and or at the very least write down the different variables and how these variables are. So that's a formal way to do the intro, is write down the variables and tell what are the relationship between the variables. Then methods. So the really formal part would be writing down the formulas that you're going to need to use for the solution, but it doesn't hurt to use some English as well here. And then results would be applying those methods, and discussion. So it's not the answer is 9, but for example, graph 1 is going towards northwest at 9 knots. So plain language answer. And in longer papers, you typically have an abstract, which is in those papers always public. So there's a little summary of what the paper is about, and then usually a non-public conclusions, which summarize the results. Usually telling that we are really reaching the state of the art here, but further research is still needed. So we're going to use exercise 7, problem 1, as a sample problem of how. So this is kind of going slightly ridiculous here, but just for effect, it's a simple problem. And we're going to briefly show you what kind of exercise answer we could do about this to get the full one. So the problem was this. This is slightly rephrased from the original. So it had slightly longer text there. So consider 2 craft. One is traveling at 20 kilometers per hour heading 20 degrees. Craft 2 is traveling 30 kilometers per hour heading 250 degrees. What are the components velocity of craft in the usual map coordinate system? Okay, so this problem in the original version says that 0 degrees points north and 90 degrees points east. But you probably in a exercise for praise, at least you would need to define your coordinate axis. We assume that okay, I have a typo there. What are components velocity of craft 2 in relation to craft 1? So first would be writing down the problem. In applied problems helps to state the relationship between variables. So and it does make if the problem on the question paper looks hard, then it's very useful for yourself to start by rephrasing the problem in terms you understand. And there's one excellent part here. Even if you understand the problem wrong, if you are solving properly the problem you stated, then you're going to lose points on this part of the solution. But hey, you knew something, and if it's relevant to what I was supposed to have you do, then you're probably getting points out of that. So you misunderstood the problem, but your solution is still correct. If you just start doing something that's entirely unrelated to what I asked, but you're missing this step, I'm going to probably give you a 0. So the previous could be stated that there are two craft without traveling in different directions. We are given the velocity vectors in polar form, so speed and heading, and we need to present them in a common coordinate system, as well as in a coordinate system that has been defined by the velocity of craft 1. Um, 10, concept and necessary methods. So solution methods. So it is a kind of a generic solution. So these problems will be solved in a that and that way. Okay, so I've here written the coordinate system. So where I do our basis vectors point. And okay, in this problem, the model solution was that we were using right angle triangle math to calculate triangles, to calculate the components. So that's one way. Or you could have stated that since these are in a polar form, which you didn't know back then when we were originally solving the problem, unless you had polar coordinates earlier, then polar coordinates can be converted to Cartesian coordinates using these two formulas and applied, and then that's it. Application is already next step. And then the B part was that, okay, we had those in component form, then we can use the dot product to calculate components, and either define the components separately, or then we could do another projection, or then we could calculate when we know one component, then we can again use right angle triangle math to calculate the other component. This part is badly written here, mainly because I want to fit on one slide, but you do not have a word limit. Of course, if your exam answer is starting to span several pages, then probably you're doing something wrong. Well, except in the Gauss elimination stuff, that takes quite a lot of paper. Okay, third step, apply the methods. So you have stated your problem, you have stated what formulas and how to apply the solution. This is something that probably is either do a pen and paper. So if you have a camera or even a scanner, that's gonna, or if you have one of those fancy kind of new stuff that allow you to easily type formulas on the computer, you can use those and put it into a PDF as long as it's not larger than 100 megabytes, and upload it on the exam. So Or if you want to really type it on the text box using the formula editor, you can also do that. Usually, this is how you find the difference between someone who was trained primarily in mathematics versus someone who was trained in maybe physics. Is that the mathematician will typically drop the units and then check the units afterwards that the units match. And if done really properly formally, we would need to carry the units all the time, but it might actually lose clarity, in my opinion, if you carry the units with the calculations. And also, you might want to draw things as well. So drawing always helps see what you're doing. And if you label your drawings, say Fig 1, Fig 2, you can then in text as well refer to see Figure 1. And then the final, most important step in real life. Okay, so you're an expert. You have calculated something for a manager who has maybe a Bachelor of Economics or Master of Economics, but let's not hold that against them. And then you're trying to explain why your solution is the one that should be taken. So you have a bunch of numbers. If you just tell that, okay, V is 12, so that's not going to mean anything. But if you tell that if we advance to that direction at 12 kilometers per hour, then we will be faster in our destination using less fuel than if we take the other route. Well, okay, that's totally made up example. So try to use simple language. So in this kind of a interpretation, if it is feasible. So this depends on what is your audience. If you're having a really technical audience, then by all means use jargon. But for practical use, try to use simple language. What does this concept mean? But okay, there's no need to go all just referencing a comic that's linked here on the below. Upgoer 5 is I'm going to actually briefly show you to come. Well, let's go through the slide first. Okay, so we had this previous problem. We've applied the methods, and so in the previous step, I didn't show that, but this would be showing your work. That's mostly what you've got on the sample solution on Moodle. And then we would list that craft 1 is traveling northeast, going north. So that's the component in that direction, and going towards east, that's the component in that direction. And then the component craft 2. And then in relation craft 1, craft 2 is heading that and that direction. And now there's a book about these. So there is a concept called simple English. It's occasionally worth practicing it. Of course, simple English probably won't have any of your mathematical terms because this is taking only a few of the most common words in the English language. So this is already overdoing it if you're trying to explain how Saturn V or here Upgoer 5 works. So US space team is probably NASA. And this is using 1,000 words people use most often, so 1,000 words. And that's somewhat eye-opening to read something like this. There's a book on it. I don't expect you to buy it. I'm not supposed to do marketing. A few of these are the free samples. So, but this is already overdoing it for comedic effects, really. And but occasionally work, especially in highly technical fields, it's worth thinking about how would we explain this to your grandma? So okay, we can okay, that might be slightly overdoing, but if you're having a fathers, mothers with a somewhat or other relatives with somewhat modern but non-specific education, then how would you explain it to them? Okay. And a nice reminder, just waving hands means that this kind of a conceptual making and not, okay, it's upper, or in some cases it's used kind of pejoratively. So okay, he's just waving hands, he doesn't know the solution, but he's just throwing around concepts. But if you're really good at waving hands, conceptualizing problems, it will be easier to solve them. So it is something we probably should practice more during the exercise session as well. And what it helps here in the exam, even if you cannot solve the problem, if you have stated correctly what the problem is and in which methods it could be solved, this always costs you points. And if you're really good at this, you're just passing the exam without actually solving stuff. Okay, but if you can solve the problems, you should try solving the problems. Some technical about, okay, I was telling people, okay, if you are going under a certain limit, you should retake the exams. But actually, if you got a 0, sorry, this is not what I told in the beginning, because apparently CISL is such a format that if you're registered a 0 in the midterms, it will not allow you to pass. So probably we could apply bonus points and so on, but that gets a bit odd. So yeah, you're gonna need to have at least 1 on both exams. Usually you are not allowed to take midterms and end terms, but we will use the next final exam dates instead to retake midterms and retake the end terms. And those exams will also be Moodle home exams. So yesterday we got the decision that, can't remember the date, but basically at least the third period, so the first period of the next year will be a remote teaching period. All right, so this is all I had to say. And together with the previous lectures, that's actually all I had to say on the entire course. And I'm actually gonna stop the recording now, but if anyone has questions, do ask.